All right, so we're going to continue these notes. We're going to do some examples. It says find the Maclaurin series for each function. So this is why we need to memorize what sine x is equal to. So we need to know about the Taylor series or the Maclaurin series that represents sine of x. So I've got to write out the first couple terms, and it will usually tell you find the first like 3 non-zero terms or the first 4 non-zero terms. That'll tell you how far out to go. But I've got to know this is the basic setup for sine, right? Plus dot, dot, dot. Now I also kind of need to know that the nth term is negative 1 to the n times x to the 2n plus 1 over 2n plus 1 factorial. And this is what they call the general term. This is the general term. These are like the first 4 non-zero terms. So that terminology is going to come up. The general term is the part with n, so in general, it's how you find the terms. And then make sure you put your dot, 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 because this is a series that goes on forever. All right, so to find sine of x squared, what we're going to do is replace all the x's with x squared. So it's like a composition of functions. I'm plugging in x squared everywhere I see an x. So this would be x squared minus, be x squared cubed over 3 factorial. And then it would be x squared to the 5th power over 5 factorial. I think I got that wrong. Okay, plus there, and this would be minus. Minus x squared to the 7th over 7 factorial plus dot, dot, dot. Negative 1 to the nth. Okay, come on. Times x squared to the 2n plus 1 over 2n plus 1 factorial. So if I'm writing the general term, I'm going to plug in that x squared for that. So this would be sine of x squared is equal to x squared minus x to the 6th over 3 factorial plus x to the 10th over 5 factorial minus x to the 14th over 7 factorial. And then I could say that general term plus dot, 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 negative 1 to the nth. And then what would this be? X to the 4n plus 2 over 2n plus 1 factorial. Plus dot, dot, dot. Don't forget that part. All right, so if I wanted to write the summation notation, it starts at 0 to infinity, negative 1 to the n, x to the 4n plus 2 over the 2n plus 1 factorial. All right, so if I wanted the first 4 non-zero terms and the general term, or if it asks for the summation notation, those are those different components. All right, let's do another one. So this one's not function composition. It's saying take the polynomial x squared and multiply it by e to the x. So x squared times x plus 1, I multiply it by all the terms in x plus 1, right? But what I'm doing here is I'm going to rewrite e to the x as a polynomial that goes on forever. So an infinite number of terms of a polynomial. And I've got to know e to the x is 1 plus x squared over 2 factorial. There's that pattern, right? And I got to know the nth term is x to the nth over n factorial plus dot, dot, dot. Okay, series. Now, if I multiply x squared times that, I'm going to multiply x squared times all the terms in the series, or in the polynomial. So it'd be x squared plus x cubed plus x to the 4th over 2 factorial plus x to the 5th over 3 factorial plus dot, dot, dot. If I multiply this by x squared, I would get x to the n plus 2 over n factorial plus dot, dot, dot. Okay, this part right here, the nth term, is hard to find if you just did it like all on your own, saying if this was 0, this was 1, this was 2. but just take your nth term. If you memorize it and you just know to multiply by x squared, then it becomes a lot easier. All right, so the summation notation would be x to the n plus 2 over n factorial. All right, so these can be tricky, just being honest with you. I'll just do 2 more on this video and then I'll break it up. Okay, find a power series for the function f, but f is e to the x minus 1. So what I'm going to do, write a power series. So basically write a series with exponents that could represent this. So I've got to look at this and realize, okay, what that's asking me to do is I've got to know e to the x is 1 plus x squared over 2 factorial plus x cubed over 3 factorial plus dot, dot, dot. And I should probably know, and I already forgot, that this is, was it x to the n over, okay, that's pretty easy, plus dot, dot, dot. All right, now I've got to subtract, so e to the x minus 1. Now I don't subtract x from all the terms, I subtract x from its like term, and I subtract 1 from its like term. So the x subtracted from that x will cancel, and the 1 minus that 1 will cancel. So what I'm going to have is x squared over 2 factorial plus x cubed over 3 factorial plus x to the 4th over 4 factorial plus dot, 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 x to the n over n factorial plus dot, dot, dot. Yeah, I think I'm okay with that. If I start with n is 1 there, or n is 0, just thinking real quick, is this might be better to write n to 0. If I subtract that, what I need to know that, just a second. Okay, I'm not sure if we need to know this part. What that would be, if I start at 0, yeah, that's not a thing. Let's don't worry about that. Let's just write it like this, just like this, plus dot, dot, dot. That's what it's equal to right there. I'm not gonna try to write the summation notation for that. All right, last one in this video. The sum of the series that is that equal to natural log of 3, e to the 3, cosine of 3, or sine of 3? So, I know cosine and sine go back and forth, back and forth, back and forth, right? And if I'm looking at it, what is this looking like? Looks like 1, that's just a 1. X, this is 3. And then that would be x squared, that's 3 squared over 2 factorial. So this looks like it's just e with 3 plugged in. So this one would just be b. All right, that's it for this video. Number 5 and number 6 are like free response questions. So they're really good. There's a lot to talk about there, but that'll be in the next video. So hopefully this made sense. And thank you for watching. Bye.